How's your body? I've lost like
Oh, yeah.
9 minutes.
Don't break a still, though.
Water.
So one of my friends broke a still like in their neck.
Yeah.
And so it just flooded inside of them. And
Is it tomorrow morning?
when she came out, she was just like, every single piece of her clothing
Okay,
was
we're gonna do it early
changed.
though.
Yeah.
I get to the rain. Okay. So I was thinking,
Guys, so I'm gonna move through the chapter here pretty quickly. So 7.6 is oil today. 7.6, oil today. Take a look at this chart. It's table 7.3. If you look at, let's just look at the Middle East. 1910, zero oil from the Middle East. 65% from the U.S., from North America, 22% from the former Soviet Union. The Middle East in 2009, 30%, U.S., Canada, Mexico, only 17%. Former Soviet Union, about the same. So you're sort of looking at the increase right now. 2009, we're looking at 38, 21 megatons per year. And so the question is, where does that go? It's coming out of the ground, and it sort of has to go somewhere. Oh, and here's one thing. Yeah, and I want to do one little bit of math. I'm just going to run through it. Follow along, please. So I'm looking at box 7.5 because this is relevant for your problem set 1. So if we're looking at 1 million barrels per day, BPD, we're just going to convert this into energy. That converts to 0.365 billion barrels per, barrels with a B, barrels per year. That's 50 million tons per year, which is, gosh, just about where we were in 1915 or so. 50 million tons per year. Now, we can convert that directly into energy. 2.1 exajoules per year. And what is that? Well, 500 exajoules per year is global. So if it were 5, that'd be 1%. So it's a little less than 0.5%. And then the next thing is to convert exajoules to quads. So that's 2 quads. So a quad is a quadrillion BPUs. So if you ever see quads, you know that's about one quad is about the same as an exajoule, and it's a quadrillion BTUs, all thermal values. All right, so here's what we're looking at. This is figure 7.2, distribution of the world's oil. This is how much there is. Middle East has or had a lot. And even though they have 56%, they don't produce that much. So there's a surplus, if you will. Here's North America with relatively modest 5.5%, but this is our production ratio. So if you listen to the radio, there's vote for energy. This is what they're these people are voting for. So vote to expand this fraction. Now, is that strategic? I mean, is that what we should be doing with our oil, or should we leave it in the ground with the assumption that it might become more valuable in the future? Well, you tell me. As if we produce faster, then it allows the Middle East to gain even more of a monopoly. So there's your price war, there's your economics, and that's the whole source of the instability. Round and round we go. Yeah. Okay. And then 7.4. 7.4 is actually a really important table. So it takes that figure we just looked at. So table 7.4. Previously, we looked at proven reserves. Remember this little figure from last week? Here's your proven reserves, what you have. If you look at this figure, so this is how much is in the bank, and this is your spending ratio. So you can almost think of this as energy and this as power. It's a pretty good way to think of it. And then table 7.4, you've got your reserves here, and you've got your production here. So back to this figure, this is R on the left, and this is P on the right. R and P. So you can come up with an RP ratio. And if we look at Saudi Arabia, they have 75 years of oil left. If you look at Venezuela, they have 200 years of oil left. I'm just going to hop right on down to the U.S. And again, these were 2009 numbers. And it's maybe a little bit misleading. So, well, the USA, 11 years of oil left. Well, that was just that was a snapshot in time. And if that's true, then gosh, we're going to run out of all of our oil in 2020. But it's just not that simple. It's dictated by global demand. It's dictated by prices. It's dictated by how much people drive, how many electric cars are built, how many people live in cities. There's just a tremendous number of factors. The UK was down here at 6 years. So that means that at those rates, the UK has zero oil left anymore. But again, it's not linear. It's just a snapshot.
Is that in their country?
What's that?
Is that in their country or just their own reserve?
Well, so according to the chart, the UK had a reserve of 0.4 million tons. So 100,000 tons of oil left in their proven reserves, which was 0.2%. And at that point, they were still producing at a rate of 68. Oops. Oh, I beg your pardon. This is actually times 1,000. Times 1,000. So 0.4. So this would be 400. Yeah, so 400 million tons, and you basically divide 400 by 68, and you get about 6. That's where that math comes from. And you would say, well, gosh, were they doing any exporting? Probably not. Not financially viable. If we go back, the UK is not listed as an exporter in 7.3, but we can then look and see what the UK is consuming. So they hit a peak there in the 70s. Again, big cars, cheap oil, etc. But it's slowly, it's just it's flattened. You can see diesel is becoming a more popular fuel. And again, that just depends on what the engine do. Diesel engines in general are more efficient, more miles per joule, if you will. But, the UK's population is relatively flat, and it looks like we've sort of peaked, if you will. Okay, key UK petroleum demand statistics. So again, they start in 1950. This is table 7.5 and go through 2009. And again, it's just a distribution of what all of the petroleum products are coming out of the ground. So take a look at that. There's an oil refinery in the UK, not too much different, but there's your towers. Here are the different tubes coming off, some of them, giving a second chance. I don't see any flares happening there at the moment, but there, you're holding tanks. Once the liquid fuels are refined, they go off to tanks and then are sold. Okay, so that's it for oil. I'm going to take a break here, and then we'll get into natural gas as well as peak oil.